Hi, in this video, we're going to talk about polymorphism. So we've already seen that in derived classes, we can override a base class methods. And in doing so, the derived class can behave differently from the base class. And as a matter of fact, if there are multiple derived classes, they can behave differently from each other. So this is an example of polymorphism. Okay, so this is an extremely useful concept and technique in programming. Now, the word polymorphism, it basically just means the ability to assume different forms or shapes. So, it's something that can look different, but it also means that it can behave differently. So let's see an example of polymorphism. Uh, well, this is just really another example of overriding a method. So for a person worries about a lot of things. Most people, the number one thing that they worry about is money. Well, most people except probably my kids. Anyway, so here is a worries method in the person's class that it returns a list of things that a person worries. So it includes money, right? Okay, so what about for a teacher? What does a teacher worry about? Well, teacher definitely worry about what most people worry about, and that is money, probably even more so than any normal people. So what a teacher worries about is whatever the normal person, the base class person worries about, plus things like I worry a lot about preparing and giving lectures. So that's another thing that I'm worried about. Okay. Now we can see that this works. Let's print out what the person worries about, right? That will be, John Doe is worries about money. And then we can also print out what a teacher is worried about. And that would be, yeah, worry about money and lectures. Now, if we have lots and lots of uh, people, right? I mean, there are a lot of people in this world, and if we have to say, print this person's worry and print this teacher's worry, that's a lot of print, right? Now, fortunately, we know how to, repeatedly do a lot of things easily, right? If we put all the teachers and all the people in a list, and then we actually write a function that would, given a list of people, will print all the worries for everybody in this list. Well, it's pretty easy for all the people in, for the person, for all the P's in the peoples, we just print out that whatever is that identifies that person worries about and whatever they worry about, right? So it's simple. And now let's, for our very small world, let's print the worries of John and the teacher. All right, so and I'm going to comment these out so we don't get all these noises. And we're just printing out whatever's in the list, which is just person and a teacher. So run this, and yes, that's it. I mean, it kind of behaves as you would expect, right? It just prints out these for these two persons what who they are and what they are worried about. Now, this thing, it might work as expected. It might look unremarkable, but if you think about it, it's kind of pretty um, cool what it actually does. Because if you look at it, this is really the same code, right? P dot worries. It really doesn't care whether it's a person or a teacher. This is the same call, P dot worries. However, this P dot worries, it behaves differently depending on what P actually is. right? So when P is a person, then P.worries does this. It returns a list of just money. Normal people just worry about money, right? When P is a teacher, then what it does is a little different from what a normal people does, right? The teacher worries about money and the lectures. So the remarkable thing is, yeah, same code, but it behaves differently. And that is what polymorphism is about. And there are many real world kind of example of polymorphism. For example, and I'm not sure, some of you might know what content management system is, but basically they just store different types of content, right? These contents could be PDF, files, the Adobe Acrobat format files, could be a Word document, could be pictures, videos, audio, all sorts of different things. Now, all of these, they are all just contents, though, so they could be all inheriting from say a base class of content or something, right? But they all store different kind of information. Now, some of these information might be common to all of them. So maybe all of these file has a creator, right? Has a created date, things like that. Maybe even size, right? However, a picture definitely is storing something very different from a Word doc, say, for example. Word docs store text mostly, right? Well, they can store pictures too, but picture is really used to store image information, so it might has dimensions and things like that. So a picture would behave very, very differently from a Word doc. And video would be even more, right? Because video not only it contains multiple images, it also can have sound and different things. So, but all of them can be stored the same way in a content management system. Now, another example, and this could be familiar to those of you who actually play games, let's say a game of Minecraft, and I'm sorry if you don't, but kind of bear with me. In Minecraft, the game, there are many different kind of blocks, right? There's the dirt block, there's a stone block, fire block, diamond block, and all sorts of different things. Now, when you, as a player of the game, you walk up and touch these blocks. So all of these blocks would probably, I'm just guessing, but they'll probably have something called a method, a method that is touched, right? And the touched method, even though it's all the same name, but it would behave differently depending on the type of the block. So a touched for a dirt block, I mean, might mean when you touch it, the dirt disappears. And if it's a stone, then nothing happens. Maybe you just cannot walk through the stone or something. If it's a fire block and you touch it, well, you get burned and maybe your health get reduced. Excuse me. And for a diamond block, then if you touch it, then you probably take the diamond and put it in your inventory, and maybe you get rich and can use it to buy other things, right? So even though it's the same, again, same kind of method, but the behavior could be totally different dependent on the type of the block. And so and one of the reasons a game like Minecraft is so much fun is that it can introduce all sorts of new type of blocks to the system over time, and all it has to do for the new block is to define a new touched method that kind of does a different thing. The game engine itself doesn't have to change at all to incorporate the new type of blocks. Now, for you to see that, I would actually ask you to do a little exercise now. So for the student class, then define a worries method that return a list of things that a student would worry about, right? You probably worry about quizzes, finals, assignments, and your grades and that sort of thing. Then you can instantiate a student instance and add it to the list of people that is passed to print worries. So please pause the video and give that a try. And assuming that you have done it, I've done it too. And now I've defined a student class, and the worries of students is whatever the person worries plus the quizzes and assignments. And here I instantiate a student, and I add the student to the list of people passed to print worries. Right? So when I run this, then it print out what a particular person worry about, a particular teacher worries about, and what a student worry about. Now, again, I hope that what's remarkable here is when I first wrote print worries, the student class did not exist at all, right? Now, and then after I wrote this function, then I added the student class, and this function here, print worries, without any modification, it is able to handle the new type student and is able to kind of print out information about this new type. So you can kind of then imagine you can add many different other types of persons, and this function will continue to be able to work to handle all of these new types as long as it defines the worries method, and we don't have to change a thing in this function. And that, I hope, gives you kind of a glimpse of the power of polymorphism. And so one more thing I want to say about, well, not even so much about polymorphism itself, but more about type checking in the world of inheritance. And that is, what if I, in the list of people that I pass to print worries, I either purposely or inadvertently pass something that is not a person, right? In this case, it's a string. Okay, so if I run this code now, as you would expect, it would crash because in here, p, it would try to do p dot worries, and if it's string, it would try to do string dot worries, but string obviously does not have a worries method. Now, in that case, it would be nice to make sure that, whatever the type of this guy, this P, is a person, right? Now, so can we do what we have been doing up to this point? Can we say, if type of P is person, then we print it, otherwise we don't. Well, if we run this, well, our code no longer excuse me, crashes, but it doesn't print everybody who is a person, because, well, the first person is a person, but the second and the third items in this list is a teacher and a student, so its type is, in that case, is not a person, it's a teacher or a student, so it's not getting printed out, and that's not good, obviously. So what we really want to check in this case is if P is an instance of person, or is an instance of a type that derives from person. So, and for that, Python has something that is slightly different. It's called isInstance, and we're checking if P is an instance of person. And because, if P is a student, well, student is a person. So in that case, this will return true. And the same for the teacher. So if we run this, then we are good. We are back to printing out these three instances, all of which they are an instance of either person or a class that derived from person, but definitely not string, because string is now derived from the person class. So with inheritance, most of the time we do not want to use type equal to check the type of an object, but rather we should most of the time use is instant to check if an object is an instance of a particular type.